Hello and welcome back to practice 2. Now, after practice 1, you should start to see that we have the logarithmic form and the exponential form, and you should be able to see these two things as one and the same. So we have a meme over here, the two Spider-Mans pointing at each other, they're actually the same, right? So why is it that we need to have two ways to write the same thing, you might ask? So the idea is very similar to the spirit of triathlon. In triathlon, you have to cycle, you have to run, you have to swim. What is the idea over there? The idea is that, say, if you have an obstacle, right, you're trying to get from some place to another place, and maybe an island to another island, you should be able to change your mode of transport, maybe swim across the water body to get to your destination. Likewise, in mathematics, say you're doing a problem and you get stuck in exponential form, then you should be able to switch to logarithmic form, carry on the problem, and say if you get stuck again, change back again to exponential form and keep working towards your solution. That is the idea of having options. So now let's look at practice 2. We're going to do more practice, more repetitive stuff. I'm sorry about that, but that's what helps to build muscle memory. And this is rather important because if you don't have this, you're going to be really confused later on when we have log laws coming in. Okay, so let's again just revise. Say if you're given this log expression, log base 2 of 8 is equals to x, and you'll be like, oh, I'm not terribly familiar with logarithms, I'm not sure what to do. Well, there's only two things that you remember, right? Number one is that look for the base. The base is literally the number written in the lowest position, in this subscript position. Sometimes in science, you might have things like A0, A1, A2. These numbers, they are written at the bottom. Yeah, they are like in a low position. Likewise, in logarithms, in the log function, we write the base at the bottom. So that's the base. Next, you also need to realize that for logarithms, it's like a machine. Sometimes I say log function because it's really just a machine. And what this machine does, if you look carefully, is that it takes in an input. In this case, I'll say it's 8. Okay, so you put 8 into this machine. This machine is rectangular. Yeah, this machine looks like that. You put things in and things come out. And this 8 will sit nicely in this bracket here. Yeah, that's where the input sits. And what comes out as a result will be x. And this x, the result or the output of the log function, is an exponent, it's a power, right? That is the second idea you need to have. So look for the base, look for the exponent, and that is all you need to change to exponential form. Because you can say that 2 to the power of x is equals to 8. And then from here, we can do simple manipulations by changing 8 to 2 to the power of 3. And by comparing powers, I can say x is equals to 3. All right, so I'm going to go through maybe just the first 3 questions for question 1 and 2. So 1 ABC, 2 ABC, and you should try to work out the rest on your own. So let's take a look at 1A. That's based on the same idea, right? I'm given a log equation, which I may not be familiar with, but I just need to apply what I just learned. And that is, I look for the base, it's over here. I look for the exponent, it is the output, the result of applying log. Then I can say that, oh, 3 to the power of 4 is equals to x. And I can use a calculator for this because the calculator can tell me what's 3 times 3 times 3 times 3. That is 81. That's the answer for 1A. Now moving on to 1B, you can see that, hey, this is the exponent and this is the base. Rewriting this in exponential form, 3 to the power of 0 is equals to x. I know this. Any number except for 0 itself raised to the power of 0 must be equals to 1. So x is equals to 1. Okay, now moving quite quickly, as you can see, because we're supposed to be building muscle memory here. So if at the start you're a bit slow, it's okay. Just try and pick up speed as you work through the 12 questions that we have over here. So moving on to C, it looks a bit complicated. Log base 2 of x over 2 equals to 3. No worries. Look for the base, look for the exponent, and this is 2 to the power of 3 is equals to x over 2. Multiplying both sides by 2, I'll get 2 to the power of 4 equals to x. So again, you can use the calculator. That will tell you x is equals to 16. Okay, so in these 12 questions, I've hidden some very nice results or outcomes. So you should make a mental note whenever you see like nice outcomes, because these are really helpful in mathematics. They're kind of like loopholes and exploits we can use later on to solve equations. Now, let's move on to question 2. Now, in question 2, what you're given all over here are log expressions. There's no equal sign, right? Either log expressions or exponential equations with log. So how do we do this? Can we still change it to exponential form? Yes, we can. You just need to recognize that, hey, this log expression is going to output, it's going to result in an answer that's going to be an exponent, which I do not know at this moment. So let's call that x. And then I can change it to exponential form, saying that 2 to the power x equals to 1. So x must be 0. Likewise for part B, let this be some exponent, which I'm going to find out. Then write it in exponential form. So x must be equals to 1. And finally for part C, let this be x. So 2 to the power x equals 2 to the power 3. X must be equals to 3. Okay, so I hope this has been helpful. Right, take some time to work through this, build a muscle memory, and then you'll be good to go for the later parts of logarithms. I hope this has been helpful, and I'll catch you on the flip-flop.